And is there any, like at the top right corner, a picture of yourself?
No, we don't see that. No.
Perfect.
Okay.
Great. So thank you. Thanks for the opportunity, and thanks for joining me and Suleiman and Alan to listen to our research. And as you can see, it's about the geographical distribution of traffic accidents in the city of Cape Town. And if I just would like to go through the contents, so I will talk about the research aims, the study area, and our data set. And I would like to talk about what we have done previously on road traffic accidents. We haven't done spatial models, but we have done only a classification model using machine learning algorithms. And then I would like to talk about actual future research and current research on point processes on the network. And we'll discuss a little bit of the theory. And then I will talk about what we have done previously and our future work with some references. So our research aims are obviously just to analyze the distribution of the traffic accidents. So what is it, how it differs from year to year, or maybe season to season, or location to location, and what the factors affecting the intensity and severity of the traffic accidents, so which we have done. And can we extend all these findings to other metro cities? So can we, academics in this room, collaborate using our findings and using data from your municipalities? And can we extend it using these analysis? And also, can we collaborate with the policymakers? So the main policymaker here is City of Cape Town Transport Department. Can we collaborate with them and present our results to them and see if our findings can be used in anywhere in their policy making? So actually, we are doing a presentation to City of Cape Town tomorrow, and we will see how we can approach to them, because obviously their interests and aims are different than ours. And why traffic accidents? So I can't not mention Professor Tim Dunn's name when I'm talking about traffic accidents, and I want to commemorate him because we lost him in 2016 at a very early young age to a very tragic accident on N1 in City of Cape Town. This was caused by a drunk driver coming from the other side. And here is a picture from N2. These N1 and N2 in the City of Cape Town are the most commonly used roads. And you can see here in this picture 3 animals. This is not an unusual scene, which I have actually experienced this myself. It was very scary, and at nighttime coming back from the airport, it was really, really scary. So these things do happen, and something has to be done about them. So what is our study area and the data set? So the study area is obviously City of Cape Town, and we're going to be in this talk focusing on especially the city center, the town center. And we have got the traffic accident data set from 2015 to 2017, and the data set was sourced from City of Cape Town Department of Transport in 2018. So you can see it's actually quite an old data set. It only covers 3 years, even though the city has a very well-developed and managed database system dealing with the road traffic accidents. Accessing these data sets still requires submission of a research proposal. It takes months. So hopefully tomorrow we're going to be able to get these data sets without this kind of obstacle. And in the database, City of Cape Town categorizes the road traffic accidents into injury severity into 4 different categories. And they also store several accident-related variables, so which are the usual variables like street name, number of drivers involved, number of passengers, a number of pedestrians involved in the accident. So using this database variables, we created several other variables, which we thought that they might be contributing to the intensity of the accidents occurring at a location, such as, is it a public holiday, is it a weekend? Is the season an important factor? The number of vehicles involved, so it comes from the number of drivers, so they don't have that number of vehicles involved. We just incorporate that. And you can use weather-related variables, which we haven't used in this analysis, so these could be used. But in the database, you will see that there's no mention of longitude or latitude. It's only the street name that is provided. So the student that was working with us back in 2021 had to convert this information to longitude and latitude information. So it's very important that this is a huge problem because the street names can be misspelled, can change from time to time. There's no like a consensus, and sometimes it is entered, misentered. So we actually lost a couple of data points due to this conversion that had to be done manually. So here we will focus tomorrow in our presentation that this needs to be improved. There needs to be a better way of storing the data in their database. So if we look at the data set, we see that 2015, 2016, and 2017, luckily the no injury case is the majority case, and fatal injury is only 0.27%. So it's a good thing, but still there are fatal injuries. So what we did previously using this road traffic accident data set is all these three we have published. So one of them was a network-based point pattern analysis presented at an international conference. It was again in COVID times, so it was a send an online document type thing. And we have also presented our findings from the thesis at another international conference in 2022. And Christopher's thesis can be found in OpenUCT. So I've got all the links at the end. I can provide these slides if anyone is interested. So what Christopher did was just a classification of the road traffic accidents, and he utilized machine learning techniques. And the main aim was to see which of the variables are useful or are contributing the most in the classification of the road traffic accidents into those 4 different categories, which are serious injury, light injury, no injury, and fatal. Now you can see that given the nature of the road traffic accidents, where the data set is very imbalanced, using standard classification algorithms like decision trees or random forests or neural networks is problematic. So you need to actually apply first some sampling methods. It could be undersampling of the majority or sampling of the minority, or synthetically creating similar data points. So we have explored all 3 different methods, and we have looked at multinomial logistic regression, classification trees, random forests, and GBMs and artificial neural networks, and we used gradient boosting methods, and we have used these R packages, and we have incorporated all 3 different sampling techniques to see which of the method sampling technique is more appropriate in or provides us better results in predicting the classes. And we have done 10-fold cross-validation, and we looked at the different model architectures. Obviously, all of these methods have some hyperparameters that needs to be tuned. All of the details are actually quite boring in my view. What we can look at the results, the comparison of the different models, we see that artificial neural networks provided the best result for synthetically generated data sets. And when we use artificial neural networks for making the predictions on the test data, we see that the overall accuracy is 76.78%. So it's not a really brilliant result, but you can still see that the fatal class, which probably the most important in this case, is really high, and no injury, which is the majority of the accidents, is also predicted well. So some of the fatal So some of the serious and slight predictions are predicted as fatal class as well. So this obviously comes with variable importances. So we wanted to find out which variables are important in making these classifications. And we saw that all 4 different models provided some sort of a different bunch of variables, but you can see that longitude and latitude in some cases started to come up as important variables. So x3 being the longitude, x11 being the latitude. So this brought us with the limitations of our study. So we didn't use any spatial techniques. We didn't look at analyzing the intensity using spatial methods. We haven't compared different types of accidents based on the linear network. So this was a huge drawback and the limitation. Obviously, that was a master's thesis that needed to be done at the time. So now me, Suleiman and Alan, we are continuing with this data set and hopefully extending it to multiple different years, not only 2015, 2016, and 2017. And the other limitations were better data collection. As I said, we only have the street name. So this needs to be improved. And we don't have information if the seatbelt was used, if the driver was drunk or there was a drug involvement. We don't have any information of driver's gender or age. So these kinds of information that needs to be improved, and I think that's what we're going to draw their attention to tomorrow. So moving on from here, as I said, we haven't used spatial techniques. What we could do using this data set is we can analyze intensity after traffic accidents. But now we need to remember that the traffic accidents happen on a linear network or on the road network. So we can't actually just analyze the intensity as a planar estimation. So it needs to be incorporated. The linear network needs to be incorporated. And after looking at that, we are analyzing the effects of different covariates on the intensity. So what is the time of the day? What is the road traffic intensity? What is the effect of these covariates on the intensity of traffic accidents? So the next research avenue that we want to explore with another student, hopefully next year, is estimation of the relative risk of different types of events. So the relative risk of day and night traffic accidents occurring in the same network. So these do occur in the same network. And all of which obviously will involve an understanding of spatial point processes along the network. So far, I've skipped the previous research that we have done, which was only on the classification quite quickly. I just want to stop here and see if there are any questions. Please don't hesitate to wait to the end. I'm happy to take the questions on that. Because it doesn't have any spatial dimension, that was very quick, in my opinion. Any questions? No. Okay. All right. Well, I will continue with the spatial techniques, and obviously I'm going to touch on the theoretical background of the point processes on a network. We know that the spatial point process X is a stochastic process, and we observe the spatial locations. It is at the moment not obviously bounded in a region. It is bounded in an L, which is the linear network. But we know that the locations of these events are called the point patterns. And sometimes these events, such as public electricity lighting, traffic accidents, vendors, they occur at locations on a linear network. So it's assuming that they're occurring on an area is a bit of a naive assumption. So we need to incorporate the information of the linear network rather than just looking at it as a space. So we have got the realization of X, so n observations of this spatial point process on the network, and our aim is to estimate the intensity of those points along the network, and then incorporating the covariates that might have an impact on the intensity. So the intensity of the spatial point patterns. So you can analyze or estimate the intensity using homogeneous intensity or inhomogeneous intensity. We all know the homogeneous intensity, it's the expected number of points falling in any nominated subset. And this is proportional with the length of the region of the subset B that we're talking about. And here the lambda is expressed as the expected number of points per unit length. So thinking that the intensity of the road traffic accidents being homogeneous is extremely naive, and we need to move on to inhomogeneous intensity, and we need to assume that the intensity spatially varies over different locations along the linear network. And it will have an intensity function lambda u, which the expected number of points in the subset B now is part of this linear network, will be provided with this integral over here. And estimation of the intensity function over here, that is lambda u, can be done nonparametrically or parametrically by proposing a specific function. And we all know that nonparametrically kernel density estimation is the most popular way to deal with the estimation of the intensity function. So now if you look at the general form of the kernel density estimate, the FU, here it will be provided with the 1 over n, the kernel density function. And this is also equivalent to just saying that the intensity can be provided with the kernel estimate. So that comes only with the assumption that the n is fixed. Now we know that the basic requirement for this to be a probability density on the linear network is that the probabilities need to be greater than 0 or equal to 0, and the mass or the area under the curve needs to be equal to 1. Now, when it comes to linear networks, now this becomes a problem. Just keep this in mind for the moment. And there is a research, obviously early studies used planar kernel density estimation, but then more recently, Xi and Yan developed a network kernel density estimation. So here you will see that the distance is incorporated along the network, and it is measured as the shortest distance from the point on the network to the observed point that we have xi. So I've gotten this picture which shows what I mean really nicely. So if you were to do the kernel density, you would take a point, use your kernel density function, and estimate this, and add all these kernel density functions and estimate the smoothed kernel density function along this region. But if you're talking about a linear network, then you need to incorporate this distance. So now there is a problem over here. Remember the basic requirement of the kernel density estimation. It had to have a total mass of 1, which means the area under the curve needs to be equal to 1. And Xi and Yan assumes that it is going to stay, it will remain valid if the real line estimation procedure is extended to a linear network. However, it has been shown that this is not the case, and the kernel density function that is provided with the shortest distance is going to be substantially different from 1. So I'll just try to explain this with a little picture over here. Take this picture. It is a linear network with 3 line segments that all come out from a single vertex, and we have 1 observed data point. And we see that this linear line, which is observed, now forks into 2. If you happen to predict the kernel or estimate a kernel density estimation with this function, what you will get is the picture on the right-hand side. And you know that here on these two forks, the kernel density extends. So it almost duplicates itself. So which means that the mass function now that had to have this property over here is never going to be equal to 1. So the mass or the probabilities will be greater than 1, which is a big problem. And several modifications have been done by these authors over here of this naive estimator. And they try to reduce the sphere bias and incorporate equal splits or heat kernels using diffusion estimators and so on. So this book by Okabe, I think is brilliant, and a very recent paper, Baddeley, has summarized all these in a nice journal paper. So I'm obviously not going to go into the details of these, but one has to keep in mind that still this method, this naive method, can be used if you've got a very big data set, for example. You can use it as a pre-analysis and try to get some inferences out of that. But you need to always remember that the this function over here, this kernel density function, will not be a probability density function. It will be a very biased. It will be biased towards the data points that are close to each other. So what we have done previously, we have presented our work as a poster presentation, as I have said, at the Applied Statistics International Conference. So this had to be a recorded presentation. We applied a network kernel density estimation following different bandwidth recommendations, so between 100 and 300 meters for urban areas. And we have only looked at some of the wards in City of Cape Town. And these are the wards that we have looked at: Bo-Kaap, Tamberskloof, and Greenpoint. For those who don't know the wards, they are basically just in the city center and very, in traffic-wise, very densely populated. So here are results. It doesn't look great in when you look at small bandwidth. So what bandwidth is, we all know the kernel density estimation. So we have chosen these bandwidths manually: 50, 100, 150, and 200. Usually one needs to do these bandwidth selection using cross-validation. However, it is taking huge time and computationally really intensive. And it has been proven that not always cross-validation is the appropriate method. So sometimes leave one out cross-validation, sometimes tenfold cross-validation, but it is computationally very intensive. So you might want to choose, instead of waiting for hours and hours, maybe days, you can just choose previously reported bandwidths. So here you can see, you can't see very well, but the center has got high density. And if you increase the bandwidth a little bit more, the density increases, and it becomes clearer that the traffic accidents over here are much denser than all the other areas. So what our future work is, we will be using the data sets using the different approaches. So as I have mentioned, so there's the Z and Yan's method. There is the heat kernel density estimation using diffusion, and also Okabe's method. And we will use all these different approaches and try to estimate with all different and compare them. And the parametric estimation of the intensity using a specific function by incorporating different covariates. So the covariates, as you might remember, the speed of the car, well, we don't have that, but the number of pedestrians involved, time of the day, the seasonal factors. So incorporating all these covariates. And so I'm not sure, we haven't looked at this temporal estimations, but that's quite a complicated process. So from 2015, 2016, and 17, and extending our data set with more yearly data and estimating temporally. So at the moment, what we have done is just taking one single year, 2015, and making the estimations and comparing these. But these can be done by just doing spatial temporal methods. And as I said, collaborating with City of Cape Town and see if we can make impact. So all in the department are a small spatial interest group, Alan, Suleiman, and myself. We are looking forward to be able to make some impact and contribute to policy making. So, oh yes, I have flown. I always fly in my presentations. Okay, so here are some references, and yeah, I would be delighted to take your questions.
Thank you, Sebnem. That was really nice. I really enjoyed it. As you know, I also work a lot on networks, and it's spatial analysis already is interesting, and then you go on a network, and it's a whole other ball game. So
yes, and it is quite interesting that nothing has been done, especially in traffic accidents in South Africa. I mean, no one has analyzed these data sets. So one reason is I have mentioned that data is messy and it needs to be dealt with, and that needs to be made aware. And how do we report traffic accidents? It's done manually, and the police just fills in this form, and handwriting is not very clear, and that gets reflected onto digital format. And our student, Krista, really struggled finding some of the street names, for example. So that's one thing. And the other thing is, if you want to estimate intensity, you can't really use an area. So you need to definitely, because not everywhere equally point appears. It only appears on the road network. So you can't actually ignore this information. And it is so surprising that when you see there's a paper out there, it's just verbally this number of accidents. There's no statistical analysis, yet alone spatial analysis on traffic accidents. So yeah, we are obviously working on it, and it is at the preliminary stage of our research, and we hope to extend this, as I said, to spatio-temporal methods, which I'm relying on Alan there and Suleiman there. Yeah, they're the temporal people in our department. Yeah.
And when you go to time, it's another whole ball game as well, because you've got your spatial correlation and then your temporal autocorrelation as well, and it's yeah.
Yes, exactly.
Very interesting.
So yes, that is basically where our research is, and we are very excited that City of Cape Town is interested. So we are actually lucky because the data science unit manager has been our student, so he actually listens to us.
That's wonderful.
When we email him, he responds. You know how they don't want to respond, or they're too busy with other things, and they are very research oriented. So we're really excited.
That's very, very cool.
I mean, yeah, since Tim Dunn's passing, it has been a thing in my mind. So how can we fix these things?
Exactly.
Yeah. Yes. All right. So I'm very happy to take questions.
Any questions from anyone?
And Alan and Suleiman, do you have anything to add?
I see there's two hands up, but first Alan.
I think he said no.
Oh, he said no. Okay. Renata,
Hi, thanks for a great presentation.
Thank
Can
you.
You hear me?
Yes.
Yes,
okay,
I can
perfect.
hear you.
Okay, great.
Suggestions, please. More than questions.
Thanks for a great presentation. It was really interesting.
Thank you.
So what I wanted to know is, because obviously a street name is not very specific. I know that's a limitation that you've had to deal with. A street could be very long. And if it doesn't happen on an intersection, then, where on that street is it? So have you thought of doing any kind of uncertainty quantification about the location of the accidents?
Okay, so let me just first share my screen, because I think I've got the data open somewhere along here. Yeah, so we haven't considered that, just an answer to your question. But if it is on an intersection, the intersection is mentioned. So that's fine. We know if it is an intersection because there are two street names are mentioned on that. But if it is just one street name, and as you said, the street can be quite long, we obviously have to take the middle of that street, and we haven't done any uncertainty checks there. I just want to show you my data if I can. So yeah, so that's basically how the data looks like. So here, if it is an intersection, you can see that it's between Main Road and Milton Road. So that's not a big problem. But if it is N1 Maitland area, so yeah, that is just taking the center of it, and we haven't dealt with that. But so that's part of the discussion. So we need to make sure that these coordinates, or where it has been happened, I think there is so much uncertainty that at least one can deal with it by better data collection instead of just fixing these things afterwards. So yeah.
There was I don't know if Renato will comment on this. There was we had a discussion with our geography department, the GIS guys, and Esri, if I remember correctly, on training a neural net to classify addresses like this, or location. So it's text analysis. So you're giving text, and then you could train it to say where the location is. That could be something that could also be interesting. I don't know how far they've got, or I haven't seen it functional, but that's a big thing in any GIS analysis. You always get data like this, where it's like a general description of the area as opposed to an actual address or an actual GPS coordinate. So that's also something in spatial analysis that needs some attention.
All right, thank you. I'm taking notes here.
Danielle?
Thank you so much for that presentation.
Thank you, Danielle.
Mine's just something that I've been wanting to get into, which I haven't been able to for a while due to time. But what about implementing, or have you considered looking at implementing some sort of spatial aspect in a machine learning model?
Yeah, so we only incorporated it using just a longitude and latitude as a variable. So there was no incorporation of the spatial aspects. But there is, so one of our other students has done the trees, decision trees, using spatial models. It takes forever to run these models. I think the better way is just seeing which of the variables contribute to intensity. I think that is much more of an interesting, and you can also compare the relative risk of fatal accidents versus no injury accidents. I can send you the reference for that, what our student has used, which didn't come out successful. I think that could be used, but there's no, it's not worthwhile using. Yeah.
Okay. Thank you.
Happy to send it to you, Danielle. I mean, that is something that could be explored if it can be improved, if it can be made to run faster. Yeah.
Thanks. Yeah, even if maybe it's looked at in a different field.
Yeah, it was looked at prices, house prices. We used it in the house prices, and it was not any better than not just adding the longitude and latitude variable as a variable. Yeah.
So it actually means that the spatial autocorrelation is being captured just in those two, in the latitude and longitude variables. We don't need to do capture it in any other way. That's simple enough to pick it up. It's interesting.
Yes. Yeah. So in the classification, that was the case. Yes.
Yeah. Because it's easier to deal with as a variable as well.
And is there any other participants here working with traffic accidents in other municipalities? I wonder.
So Renata's got a hand up. We do a lot of crime locations, not necessarily traffic accidents. Also on with network analysis, but maybe let's see what Renata has to say. Renata?
Okay.
Hi. Sorry, yes, so I put my hand up before the traffic accident question.
Yes, sure.
I know there's a lot of literature on it, but not in South Africa, obviously, as you will have noticed. What I was thinking of was just a random idea. A way of maybe getting around, or not getting around the longitude, latitude, or the spatial problem, but another way of thinking about a road network might be representing it as a graph, because I'm thinking a simpler way than dealing with a spatial computation is dealing with graph computation. And if you represent the streets as nodes in a graph, then you can see whether things like how central the street is or any other characteristic of the street, but specifically the street's relationships to each other, how that influences the number of accidents, which would be a lot simpler. It will lose some information, but it might be a lot simpler than doing a fully spatial calculation.
So nodes and segments, I believe.
And segments,
Okay.
Yes, so I was thinking of representing the segments where accidents occur as the nodes, and then the relationships between them are the edges.
Oh, okay.
I've seen that done in a paper somewhere. I don't remember which one.
But you drop the road network, or you keep the road.
No, you keep. So that's the thing. You lose the spatial shape of the roads, but you keep the relationships between them spatially. Like basically the graph captures the topology.
Yes.
So you'll lose information like road length or whatever, but you can do something like between a centrality, because I assume the more central the road is, the higher risk you have of accidents, things like that. Just a random thought.
Nice thought. Very nice.
Alan, any ideas on this?
Absolutely. I think it's doable, and inherently that's what we will try to do, especially considering that if we do a subset analysis, there's no generalization that actually occurs in that space. As you go further out from the city bowl, the density of road becomes much, much smaller, and you have longer stretches of roads. So the relationships between road and the nodes and all of those additional properties will become more important in those kinds of setups. So definitely those will be things that we take into consideration. I think inherently it all boils down to what the intention of the analysis is in a particular context. If it's for infrastructure development or if it's for mitigation efforts to minimize occurrences, those will inform how the graph theory approach translates into policy relevant results, essentially. But essentially, they are possible, and they will retain some of the spatial information as much as the data allows us to do. The one other thing that we've been thinking about is with respect to the locations themselves, you have the EMS aspect of things where an ambulance goes to pick up people who are injured or fatalities from the accident locations. So enriching, this particular data with that kind of data, as well as looking at intensity maps from probably Google or TomTom, wherever there's an accident, they basically give us a sense of what's happened at that location, and one can more accurately use that to adjust using some Bayesian methods.
Bayesian,
yeah,
yes, that's...
Yeah. So I think these ideas are very practical, and one just has to look at it in terms of the bigger picture and the study area. Yes.
Yeah, Bayesian never comes to my mind, but that's very important aspect of future work, and I haven't mentioned it there. Yeah, thank you. Thanks, Lemon.
Sibuyile?
Thank you. Mine is less about the graph theory and just asking whether you integrated some information on the type of road that you're going to be analyzing. Because when I look at data set like OpenStreetMap, they have different classifications of what the road is and what type of road it is, whether or not that will influence your results when you do the modeling afterwards.
Absolutely.
So I think that might be. And the other one is around the land use or the classification of economic activity near the network. So does that influence the likelihood of a fatal accident or not? Perhaps that's something the city can provide information on. So you could get an estimation in terms of how many businesses are registered within a certain window close to that accident point, or is it a residential area, and so on and so forth.
Yeah, absolutely. Thank you. Those are the important points. So, like, so when you look at the public holidays, so why do we incorporate the public holiday information? That's just because people tend to drink and get drunk and still drive cars and vehicles. So for that, you could incorporate the liquor stores. So that kind of information is definitely very important and very it needs to be used. Yes, absolutely. And yeah, economic activity, obviously, yeah, city center. That's why we have chosen the city center.
Pravesh?
Okay, no, thanks. And thanks very much for the talk. It was very enlightening and very interesting work that you guys are doing. So well done on that.
Thank you, Pravesh.
You asked a question regarding anyone that's doing similar type of work in terms of traffic and so on. I don't know, but I can introduce you to Magenta, who's at CSR, who's leading a group on transport operations. And I know previously that they didn't have a research group on road safety and that sort of thing, but well, actually, they had a group, they closed it, they opened it again, and they closed it again. The reason is it's a very important topic, and it's good to have such research that's going on. But the problem is no one is prepared to pay for that research. So and with CSR, the thing is you need income to come in, so someone has to pay for it at the end of the day. So that was always the challenge in terms of road safety. So he would probably be able to link you up, either in his group if he's still doing bits and pieces of the work, or outside. He would have a good knowledge. So I'll link you up with Mateta, and then you can take it from there. I was also going to ask a question about land use and so on, but it's been asked, and you've given a nice answer regarding that, because my group is more in terms of spatial planning, and land use is an important aspect that comes in. But what I was very intrigued is the issue that you discussed on the probability density function. And from what I understand, there is no solution to that problem at this moment. Is that correct?
Yeah, so there is a paper by Okabe, and actually, sorry, it's a book saying statistical and computational methods. So there are approaches. So you can't just say this is the answer. So they approached it in different ways, and so it's still ongoing. So I think theoretically there is a lot that one can explore there, and that is. So this research that we talked about isn't applied, but we in our minds actually want to get onto the theory side of it. So is there another way that we can explore? And that is absolutely not solved, I don't think. And also the other thing is, which kernel do you use? Which bandwidth do you use? Still, those issues are problematic, but the book that I mentioned by Okabe, computational and statistical, shows that these are approaches to this problem. And some of them say equal split. So remember the tails of the fork? So that density is now split into, in equal split method, into two equal parts. So is that actually the right way? Surely it's just an approach, a better approach. So the answer is, I think I can clearly say that there is research to be done there theoretically. And like Max Wigan, Adderley, Adderley, they all have been publishing still. And everyone is claiming that the previous one is actually not the best. So Okabe's equal split is also shown to be not sufficient or biased. Let's put it that way. Yeah, theoretically there is avenue to explore here.
Yeah, Badley's got that. What did you call it? That flow
diffusion
one.
Yeah.
Does that work on the? And I know he's done it in aerial shapes. Does it work on the linear network?
Yes, yeah, so it does. It's shown by Max Wigan, the PhD student of his from Australia, has been shown that it works better than some of the previous methods, yes. And also it can be adapted to, since it's a diffusion, it can be adapted to temporal data sets.
Yeah, that's an argument for it.
Yeah, so there's definitely a lot there, especially if you are now talking about relative risk, for example. Yeah, Bayesian methods, as Suleiman mentioned, are, I think, the ones that are coming next here.
Yeah.
And yeah, I would be very happy to chat to anyone who is interested in collaborating. I'm sure Alan and Suleiman also. It would be great. I mean, these presentations, I think, are supposed to be to exchange ideas and to come together and to make sure that we work together. These are important topics. And we, as the doctoral seminar group, we have established that we don't talk to each other, even in the department.
Absolutely.
So it's very important.
So I think for everyone, so we do a lot of spatial network analysis as well. And so Renata's doing her PhD is basically roads.
Which I'm aware of.
Yeah. And very recently there's an R package called SF Networks, which is a combination of SF and iGraph in R, but it's brand new. So I think the reason that none of this has happened yet is that there hasn't actually been an easy way for people to do the analysis and test things and stuff. And I think, now it's there. So we're actually at a point where a lot of people might jump on this type of research, but we already see the gap. So if we in South Africa contribute towards this, I think there's so many things in network analysis that's not well developed theoretically. The GIS people can do stuff in ArcGIS. I mean, they've got roads and stuff sorted already, but the actual statistical analysis is not in place. Yeah.
So we are actually using the SPATStat package, which is developed so that it allows you to incorporate covariates in your kernel density estimation and in your parametric model estimation. So you basically can get a model in SPATStat along a network. So you first create your network. It can be from OpenStreetMaps, and then have your point pattern, the accident point pattern data, and then merge the two or collapse the two, overlap the two together, and then analyze it using SPATStat. We have used SP Network before, and I think there's another package, which I have forgotten the name now, for like exploratory analysis. But our aim is obviously to move on from exploratory to be able to say these is covariates. You need to look at these things. Is there a traffic light? Is there a pedestrian walk? Is there a bridge? So these, hopefully tomorrow we'll get them on board, and their names will be on anything that will be published. So hopefully they will be interested. Yeah.
You've got a very nice collaboration there. I think that's really, it's difficult to get something like that in place. So
yes.
All right, I see we're 2 minutes. Okay, thank you everybody. This will be our last Spatial Stats seminar for the year, because it's November and SASA conference is in 3 weeks time. Is it? Yes, 3 weeks time. So hopefully see a lot of you there. Otherwise, obviously beginning of next year we'll have some more seminars as well. If anyone has any suggestions of speakers, would like to volunteer as a speaker, topics you want some information on that we can source someone, please just pop us an email, let us know, and we're very happy to try and make a nice community going here. So thank you, Sebnem. Thank you, Alan.
I just want to say thank you to everyone who contributed. Really nice points. And yeah, here you can see one of my collaborators, Suleiman. Georgie, our PhD student, me and Suleiman's PhD student. She's also working on some spatial, and Alan, the other collaborator. Yeah. Thank you, Inga, for the opportunity, and thanks for bearing with me, listening to my Turkish accent and all that.
It was wonderful. Thank you, everybody. Have a lovely afternoon. Bye.
Thank you. Bye.
Thanks, everyone. Bye.
Right.
Thank you. Bye.